Hello everyone. In today's video, we are going to discuss about Kubernetes. This is one of the tools we are using in DevOps methodology. Let's see what are the topics we are going to cover in this video. So, what is Kubernetes? Why we need Kubernetes? Features of Kubernetes. Then architecture, workflow, and what are the kinds we are using in Kubernetes. What is Kubernetes? It is a open source tool that helps manage application in a container, make it easier to automate tasks like deploying, scaling, and running application across different multiple machines. This is developed by Google. It's now widely used for managing large scale applications, especially in a cloud environment. And it is a flexible, works on different platforms like AWS, Azure, Google Cloud, or even on your own servers. And it is also known as K8s. Um, why we need Kubernetes? Kubernetes have auto scaling capacity in the case of container loss without releasing the resource to others, and also it has auto scale of resource when required. Additionally, host operating system initially check for available memory to create a new container. If memory not satisfied, it won't allow to create a container. One of the most benefit Kubernetes is that it's make build and run complex application much simple way. What are the features of Kubernetes? A container management, auto scaling, load balancing, service discovery, and self healing. Let's see one by one. Container management. Kubernetes help you run and manage application in containers across multiple machines. Auto scaling. It can automatically adjust the number of running container based on demand. Load balancing. Kubernetes distributes incoming traffic evenly across container to prevent overload. Service discovery. It helps container find and communicate with other easily. Self-healing. If a container fails, Kubernetes automatically replaces it to keep the applications running smoothly. Together, all these features make Kubernetes a powerful platform for deploying and managing containerized application, promoting efficiently scalability and reliability in modern software development. So, this is the Kubernetes architecture. Let's describe each and everything. What are they going to do? kubectl API dashboard. These are the way tools to send manifest file to Kubernetes from host operating system. So the next is Kubernetes Master. The Kubernetes Master is responsible for managing the cluster and coordinating tasks such as it can be a scheduling, scaling, and updating. etcd. This is the key value store that all cluster data configuration and states. Kube API server. It is the front end of the Kubernetes control plane which exposes the Kubernetes API. All administrative operations are handled by API servers. It is the entry point for kubectl and dashboards. So controller. The controller ensures that the desired state matches the current state of the cluster. For example, if a pod goes down, the controller ensures that a new one is started or not. Scheduler. These components assign works to the nodes in the cluster. It decides which pod goes to which node based on resource availability and constraints. So the next is work nodes. These are the nodes where the actual work happens. Each work node run the necessary services to manage and run the containerized application. The next one is kubelet. This is an agent that run on each work node and it communicates with the Kubernetes master to ensure that the container are running in a pod. So the next is kubeproxy. It maintains network rule on the nodes and handle network communication to allow the pods to interact both internally with the cluster and externally. So the next are Pods. Pods are the smallest deploy units in a Kubernetes, and they encapsulate one or more container. Each work nodes run several pods in this architecture. The pod 1, pod 2 are shown running on both worker and work 2 nodes. Each pod contains one or more container. In this image, pod 1 has two container 1 and container 2, while the pod 2 has one container. So these are the architecture. So firstly, the user submit desired state by kubectl or API call. Kube API server validates and update these desired states in etcd. Scheduler assign the workloads, that is pod to work node. Controller manager ensure the actual state matches the desired state. kubectl works on nodes, pulls image, creates and monitor contains in the pod. Kube's proxy manage networking pod communication. Pods are self-monitored and automatically scaled or yield based on defined configuration. This entire workflow is designed to be highly automated, scalable, and resilient, ensuring that application remains up and running even in the face of the failure increased demands. So the next one is K8 as services. Kubernetes is a tool for managing containerized applications. In this we have three types. One is pod deployment and services. Um, to view the components, we have these commands: kubectl get pods -a. This list out all the pods that which we have are running or stopped. It will show. To view the IP address of pods, we need to use kubectl get pod -o. While once the pod is created and got assigned with the IP address, same IP cannot be used for even after pod is deleted or crashed. So the first service is pod. It's the smallest deploy unit in a Kubernetes. It represents a single instance of a running process in your cluster and can contain one or more containers. Pods are used to manage the container that makes up applications. So let's see how to deploy this in a Kubernetes. Let's go and see. Go to your EC2 instance. So we need to create one instance. So let's create one instance. Give the name. Select Ubuntu machine. In this you need to select a T3 medium. If you have an existing key pair, select that, or else create a new key pair. Launch instance. Go and connect this one. We need to install Docker on Ubuntu. So go to this one, scroll down. You can see the install using the apt repository. Before you install Docker engine for the first time on the host machine, you need to set up the Docker repository. After, you need to install, update the repository. Copy this one. The next thing is we need to install the Docker package. Copy this. The next, the verify that the Docker engine installation is successful by running the hello world image. Copy this. Incorrectly. So next thing is sudo install kubectl hyphen hyphen classic. Install kubectl using the snap package manager with classic configment. Sudo executes the command with superuser privileges. Snap, the package manager for installing software package in a containerized environment. Install tells snap to install the specified package. kubectl, the package name for the kubectl command line Kubernetes tool. So hyphen hyphen classic installs a package with classic confinement with give the application border system access typically required for the development tool. This command allow you to manage kubectl Kubernetes cluster. So to install Kubernetes, first we need to install Minikube software on the server. Let's go and create a Minikube. So let's come here, copy this code, start our server, that is Minikube server. The thing that we don't have a drives, so copy this one sudo user mode from till here to here, hit enter. Sudo user mode till docker, copy this. So copy this sudo steer. Try to start Minikube start. Let's wait few minutes. Minikube has been started and it's download the Kubernetes. Let's write a command kubectl hyphen A. So this will list out all the pods including and running. So these all the commands are running now. We have been talked about services. So go to type Kubernetes pod. So using pod, copy this code. This YML file defines a Kubernetes pods configuration API version v1. Specify the API version for the resource, in this case version 1 of the core Kubernetes API. Kind pod. The kind of the resource being created in a pod. Metadata. Metadata about the pod such as its name is Nginx, this name of the pod, the specification or definition of the pod, container, the list of containers that will run in a pod, name Nginx, the name of the container is Nginx, image Nginx 1.14.2 as the container uses the Nginx version, port, list of the ports that container expose, container port 80. This container listens on the port number 80. Let's save and come out. Now write the command kubectl apply hyphen f pod dot yml. So it is created. If you want to see the created pod, write a command kubectl get pod hyphen o wide. So this will show the Nginx is created. So let's delete this pod. Kubectl delete pod. The pod is deleted. The pod is deleted. So once the pod is deleted or crashed, we cannot regain that one. That are the disadvantages of pods, and we have several disadvantages. Drawbacks of pods: no more manual work, no automation recovery, that means self healing, no automatic scaling, no load balancing. You have to handle everything yourself, like restarting the pod if it crashes, scaling the number of pods, or updating the app. No automatic recovery, that is self healing. If a pod stops working, Kubernetes won't automatically restart it, so you need to do it manually. No automatic scaling. You cannot easily increase or decrease the number of pods based on the demand. You have to manually add or remove them. No load balancing. Without extra configuration, Kubernetes won't automatically distribute traffic between multiple pods, which can cause one pod to get overloaded. These are all the drawbacks of the pods. To overcome those issues, we make use of deployment. The next kind is deployments. Here we can create multiple pods, and it has an auto scaling feature in case of pod crashes. So let's go and create a manifest file for deployment. Create a manifest file for deployment. Vi deployment.yml. The API version is v1. Kind it indicates for deployment. Metadata contains deployment metadata, and the Nginx, the name of the deployment is Nginx deployment. A label to organize and categorize the deployment. Uh, Next one is specification and replicas. Here we are going to create a three pods. Selector defines how the deployment identifies the pods in managers. Match lab, the deployment selects pods that have the label app nginx. Next one is template. The template of creating the pod, metadata of the pod such as label. Specification defines the specification for the pod. Container lists the container that will run inside the pod. The name nginx for the container, and the version 1.14.2. Port container port will listen for the 80. So we need to apply this. For that one, kubectl apply -f deployment dot yml. So kubectl get pods -o wide. See, the pods are created. Low. So let's try to delete one pod. Kubectl delete pod. The pod has been deleted, and another pod has been created. What are the drawbacks of deployment? When the pod crashes and auto yield, a new IP will be assigned to that pod. Thus, the create for the issue accessing the websites which is running in the pod manually. We need to configure the IP where the crashes has happened. To overcome this issue, we have advanced tool that is called service or a load balancing. Service. A service is a Kubernetes ensure that your applications are used to accessible, scalable, and resilient to change in underlying infrastructure. In Kubernetes, a service is method for exposing a network application that is running in one or more in your pod cluster. So let's see how to create a pod YAML file. Vi service.yml. API version 1, and here we are using a kind service that defines the kind of the Kubernetes objects. Metadata contain the object, and the name is the Nginx deployment. Specification, the detail to how the service operates. Selector, these selector pods that have the label app Nginx, it matches these services pod with the label port. Defines the ports the service will expose. Protocol, you are using TCP, and the service will expose in externally in the port number 80, and the target port is 80. Apply this. So it is created. Let's go and run this. So it is created. The next thing is kubectl get svc. The short form for the services svc. This command kubectl get svc list all the services in the current Kubernetes namespace. The get svc retrieves information about all the services in the current namespace. So here we have a cluster IPs. It's the collection of pod. All the pods have IP addresses. Let's get into the mini cube SSH. So these command allow you to open an SSH session into the virtual machine running your Minikube Kubernetes cluster. Enter. So for this, curl hyphen L HTTP, copy this IP address followed by 80. So in this service port, we cannot access the IP address directly. So for that we need a node port. So create a node service. So here the IP version is v1 and the kind we are using here service. Metadata contains information about the services name nginx specification. Here the type is node port. These expose the service on the static port on each node in the cluster. Selector defines which pod other service will target. Nginx select pod within the node nginx. And here we are using TCP protocol, and the port the service will expose internally with the cluster 80. The port on the container to which the traffic should be routed to the target port is 80. So the node port 3 static port, this will expose the service each Kubernetes row. Traffic can access this service using 3000 31,000. CTL apply hyphen F node service dot YML. So it's configured. kubectl get svc. So see the node port is created. Minikube IP. This is the IP address. Copy this IP address followed by a node port number. So this will access the outside, it can access outside, so it will show you. This is how we can configure pod deployment and servicing Kubernetes. Thank you.